Okay, so I'm going to explain the matrix multiplication algorithm. So in order to understand matrix multiplication, you first need to understand regular mathematical matrix multiplication. Okay, I don't know what I say. Okay, so especially for those who take WTW 114, y'all wouldn't know this, but so the way you multiply matrices, right? You take you multiply each row of A by each column of B. And also I must state this is also important. Unlike with like multiplication where A times B is equal to B times A, right? Let's say A is a matrix and B is a capital B. Capital A is a matrix, capital B is a matrix. Capital A times capital B is not equal to capital B. My bad. There. Yeah, yeah. You can test this at home, right? You can test. What did Prof G say in that one? Like she said, convince yourself of this at home. Yeah, you can convince yourself of that. Anyway, you multiply each row of A by each column of B. I'm going to explain it the way that the guys in who do WTW 134 explained it to me, because I had a different method that I just learned from YouTube or whatever, but it results in the same answer. So, for example, let's say I want to multiply these two matrices, A times B. So we want to first multiply this column, that row by this column. So it's going to be 1 times 9, 9, plus 2 times 6, that's 12, plus 3 times 3, that's 9, right? Yeah, that whole thing is just equal to 30. Yo, huskies. That whole thing is just equal to 30. And then we're going to multiply this the next row by the same column. The next column in B by the same row in A. 1 times 8, that's 8. 2 times 5, that's 10. 3 times 2, that's 6. That is going to be equal to 24, right? Then same deal, we do it with the third column. 1 times 7, 7. 2 times 4, 8. 3 times 1 is 3. That there is 18. Testing my arithmetic here. Okay, and then you just continue like that basically. So what I want you to notice with matrices is that you are iterating 3 different times. Let me just try get 3 different colors. So firstly, the first iteration is the biggest one, which is we're iterating through each row of A, right? And if you noticed, we got through this whole row here without iterating through A once. I mean, yeah, without moving through A once. So we see that it moves the least, because if I were to continue, we'd multiply this row by this row and then we do that. But my whole point is that we A moves the least, right? So we're going through these, and then the next ones, or the next iterations, are the iterations through the columns of B. And this happens 3 times. This happens, okay, it happens n times, where n is the number of columns, um uh, per iteration through A, right? So what I want you to notice is that for each iteration in A, there are as many iterations through B as there are columns, right? And then there's a third iteration, which is through each individual element, right? When we multiply each element in the column and each element in the column and row with the other element. Yeah, you get what I mean. Also, something I forgot to notice: in order to multiply matrices, this here must hold true. The number of columns in A has to be equal to the number of rows in B. So you would have to have an if statement testing whether this is true. Like you say, if this is not true, right? My bad. This is not true, then see out some error message, right? That, yeah. That's just something to keep in mind. And also, the resulting matrix will have the same number of rows as A and the same number of columns as B. Alright, now onto the actual algorithm. So as I was explaining, the outermost, so there's going to be 3 loops. We already established that. The outermost loop we're going to call loop K, because we're going to use K as the looping variable. It's going to loop through the rows of A, as we already said here. It's going to loop through the things of A, and then we're going to call J the one that loops through B, right? We see that B is inside A because I said that B iterates more times than A, right? And then this one is going to be loop I, which iterates through the columns of A slash rows of B. The reason it's both of them is because, like I said, they have to be equal, so you can use either one. So as for the algorithm, let's just move this here. The algorithm, we're not gonna use this like any flow diagram thing. I'm gonna write this thing out. So we're just gonna put it into some function, void multiply matrices. Okay, so basically this thing presupposes that there are already some matrices with some constant variables declared called rows A calls A and rows B and calls B, right? Okay. So int matrix A. Okay, I don't whatever, bro. Okay. I feel like I'm going to just skip. Okay, so we have the function declaration thing declared here. Okay, the reason I made like a different variable RA is one that we're going to use inside the thing. This one, this RSA, no, what am I saying? These are rows A calls A, this one should be rows A here and calls B here. So those ones are constants that are assumed to be declared outside of the algorithm, like ahead of the algorithm and all that. So like we said, going back to this diagram, we're going to have a for loop with int k equals to, so okay, I'm just gonna pause and skip to it now. Okay, so if you look here, like I said, k controls the rows of A. That's why while k is less than the rows of A. Let me just fill in the next part. Okay, so then the next part, we have the inner loop J controls the columns of B, because like I said, you go look here, then you go through there, there, and now the next part we're going to implement is the loop that we look here, we look at A, then we look at B, then we're going to implement the loop that looks at each individual element of B. There. Okay, so now I've added this thing here. This thing just goes to the position in the matrix that we're currently adding. So it's going to go here, 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 here. The reason we set it to 0 is because remember, it gets the sum. So we're going to in the next for loop, we're going to sum the values of all of the products, right? Oh my gosh, I made a mistake here. Sorry. Our I is less than. Remember, I told you this one could be columns of A or rows of B, since they have to be equal. So it doesn't really matter. You can say rows of B, I plus plus. And then now we say matrix C K J is equal to, let's just remove that. Sorry, plus equal to, because remember we want the sum, so it has to add all of the things together. So yeah, including obviously adding itself to the thing. So then we have matrix A times matrix B. By the way, I don't know if this is the exact algorithm that Dr. Marshall used. This is one that I came up with myself, so don't need to worry about plagiarism and that. You get, I'm joking. Anyway, yeah, that's the algorithm, right? I'll screen record an example of it working on my laptop. Yeah.